I saw one of these ultrasonic modules for the Pi, an HC-SR04, at my local Pi store, and thought it would be fun, so I picked one up and did some research on it, and thought you might be interested in seeing how this works and using it in your own Pi experiments. Yeah, the first thing on the tour to notice is it's got a transmitter, T, and a receiver. And it's got 4 pins. You can see VCC, trigger, echo, and ground. And that's pretty much it. It does run on 5 volts, so it's kind of an unusual thing. Most of the Pi stuff runs on 3 volts. So because it runs on 5 volts, the Pi will supply 5 volts, but you have to be really careful that you cannot feed back the full 5 volts into an input pin on the Pi, or you'll burn it up. So you have to have a voltage divider, which we'll see back here. So here are the 4 pins. See if I can get a good view of it. Not really. There are the 4 pins. You can see the ground, which is the black wire over here. Black wire, that's the first one. The second one is the first part of the voltage divider, and that should be the echo. Yes, echo. And then the next pin is the trigger, which sends out the sonic pulses. It's the thing that starts the sonic pulses running. And then the red wire is just our 5 volts from the Pi. So those are the 4 connections. Now let's look closely at this voltage divider. We have a 4.7K resistor, if my memory serves, coming out of the echo, and it goes down to the yellow wire, which this yellow wire, which I'm going to wiggle, this yellow wire goes to the Pi, and it's one of our inputs. And then we have a 10K ohm resistor right here, which goes to ground. So that's pretty much the wiring. Of course, I'll include diagrams and pictures at the end of the video, but that's the walk around of the hardware component. And I think I'm going to have several videos that use this hardware. And then on the Pi side, we just have the 4 wires going in. We have this is the 5 volts from the Pi. This is the ground. On some things I use pin 6 as the ground. On some I use pin 30 down here. Same ground, doesn't matter. It was just whichever made the picture or the diagram look cleaner. And on the other side we have the trigger, the blue wire. It looks greenish, but it's blue wire for the trigger and the yellow wire for the echo, as we saw earlier. So that's it for the hardware. Not too terrible, a little bit more complex than some things. Got to really be careful about this 5 volts and using the voltage divider, because if you bring back in this echo at 5 volts, it will damage your Pi. So you really got to be careful with that one. Okay, here's our ultrasonic setup, and let me get the software running. This is a very simple setup. I am, right now it's measuring the wall behind us, so it's doing a pretty good job. The maximum distance is about 4 meters, so it's pretty close to the max right now, measuring that wall. The software is very simple. Every reading is just a one-shot. I'm not like taking several readings and then averaging them. I'm just taking a simple measurement about every 2 seconds, and as you can see, it'll measure up close. I think the minimum is about 2 centimeters. But you could use this to, for example, measure water in a water tank, the level of water in a water tank without touching it. You could measure the height of people without touching them. You could mount this on the ceiling or wall and point it down at their heads, and it would tell you how tall they are. And of course people use them in robots, things like that, to locate walls. And it seems to be pretty accurate. Okay, well, we've talked about the software. Let's go take a look at it in detail and see what's going on. I think there's another couple projects in here, and it'll mostly be software changes. We'll reuse the same hardware, but okay, on to the software. This is the software. It's written in Python 3. Just some comments up here as usual. The red stuff that begins with a hashtag is a comment. Output ping is on pin 11. I'm going to listen on pin 13, and I'm going to use either pin 6 or pin 30 as ground. Doesn't matter either way. I've done both. 5 volts for the ultrasonic. We're using the pin 2, which is a 5 volt source on the Raspberry Pi, and the trig pin to the RPI is pin 11, and we already went through that on the hardware. Again, the caution is this 5 volts, if it does not go through that voltage divider, will kill your Pi, so be careful with that. Here's my comment: echo must go through the voltage divider circuit. Here's a comment that just tells me about the hardware. We've already reviewed that, so we'll go on. So once again, we're going to import the RPI GPIO. We're going to import the time function. I'm going to use the board numbering system. So that's the hardware pin numbering system on the board. And my triggering is going to be on pin 11. So I'm setting trig to equal to pin 11 and echo to pin 13. My offset, so I measured how far away from the ultrasonic ports, in other words how accurate it is, and this is my calibration for the accuracy of them. So I subtract 0.6 later on, and I also rounded this to 2 decimal places. Okay, so here's where I set my trigger to output and my echo pin to input. And I'm using a loop. You could use a while true or something if you want to lock this into an infinite loop. I don't like infinite loops, but okay. So I'm going to read 50 times. I'm going to tell whoever's watching that I'm setting up the system, and then I'm going to say trigger false. So in other words, the trigger is low, and then I'm going to wait for 2 seconds. So I'm going to warn the human being, and I'm also going to allow the system to settle down, if you will. Okay, here I'm just going to print a message saying that I'm getting ready to ping, and here I set the trigger to true, and I ping for a 10 microsecond trigger pulse. So this is the amount of pulse that you need to trigger the ping, and then I'm going to set it back to false. So here I'm initiating the ping. So the ping has happened. Okay, so down here, these 2 while statements. The first while statement is start listening. So I'm going to grab the time for listening. So the ping has happened. Now I'm going to say, okay, start the clock, and measure how long it takes for that ping to come back. So this is the beginning of the wait time, and this is when I hear the ping. So I'm going to grab the time, and the difference, of course, between these is the total time it took the ping to go out, strike something, and come back. That's a two-way trip, and we're going to have to remember that because that's important. Okay, so we have when we sent the ping, and we have when the ping came back, and then I just print another message saying I finished reading or finished that particular reading. And now I calculate the pulse width, which is the amount of time it took for that round trip ping to go out and come back. Just a message here to myself that the sea level speed of sound is 3,400 or 34,300 centimeters per second, and a round trip, that's the round trip. We want half of that, right? Because it goes out, and that's the distance. If you measure out and back, you get twice the distance, which is no good. You're trying to measure only the distance out. So, okay, so we're going to have to do that. We're going to take half the round trip, which is 17,150. So my distance is the pulse width times the 17,150. I'm going to round that, and I'm going to take the offset. Remember we did the offset earlier, that 0.6, so we're going to subtract that from the distance. And then I rounded it to 1 decimal place because that's enough. That's within the accuracy of the device. If the distance is greater than 2 centimeters and distance is less than 400 centimeters, that's okay. It's within the safe range or the measurable range. So I print out the distance, and otherwise if it's too short or too long, I print it's out of range, it's an error condition. And I'm going to loop this, go back up here a little bit, I'm going to loop starting here down to here X number of times, in this case 50 times. And when it's looped, done the 50 readings, then I'm going to do the GPIO cleanup. I'm going to reset all my ports, and I'm going to print done to let myself know that the program finished normally. So that's it. A little bit longer, a little bit more complex than some of the stuff we've done. So, okay, well that's it for the software and the hardware, and I hope you found it interesting and useful in your Raspberry Pi experiments.